Hi there, Liam O'Gogan here. 1, there's no 5-minute jobs. 2, there's no 5-minute jobs. So that's what this video is about. What I hope would be a 5-minute job turned into something much longer, so I decided to make a video about it. So to start off, this was only one of many 5-minute jobs, like this one here, or this one here, or even this one here, where I'm working around with all these little bits and pieces. Hello, Diego. Diego is wandering around. Even this chair, or these chairs. Anyway, that's not this 5-minute job. This 5-minute job was emerged out of another 5-minute job. So this material here, which you see, this is just the sort of matting you put down in gardens. So I'm going to hopefully put that up on an attic up in my garage, which I've put insulation into, and I just want to cover it off with that. So I thought I had a bright idea that I would use this material here and literally staple it to the wood as I went along. So anyway, this is the 5-minute job. Okay, so we started off with this thing here, just in case you need to know the number. It's a Craft PET 200. So it's a staple gun, electric staple gun. And I had the great idea that I would just go along like this and bang, 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 and just stick everything in. And I had it down in the men's shed recently doing something. It stopped working. So I brought it home and then I opened it up. So I told you, no 5-minute job. So here's all the screws that came out of it. So at least I have my little magnetic container here to hold all the screws. But I find with these things here that I usually know how they work after I've broken the first one. So I think I'd be an expert at fixing things if I got enough of the same model. It used to be the same with laptops and everything. And it was interesting. I never asked myself how this thing operated. Never at all. So just you might be interested in the simplicity of the exercise. You get electricity coming from your 220-volt socket. You come along here. You have a switch which you have to have the safety element of it, so you have to plug that. Now it's not plugged in here. And then close the switch. You can hear the little switch. And then what that does is through an electronic board here. So I've got an electronic board. Now I've lifted these out and just put this back in. This obviously goes back in here. And the electronic board goes back in there. I'll show you something about this in a moment. Pull the trigger, and then what it does is it gives an impulse into this solenoid. That's all. It gives an input into a solenoid. So a magnetic solenoid means that when you apply current to this coil, it becomes magnetic, and inside there's a ferrous core, which is then suddenly catapulted forward. So you can see that there, that's catapulted forward. And inside, let me see if I can see, you'll see that little element there. That as I catapult that forward, it shoots forward and pushes the nail out, which is held between these two little pieces here. So they're inside to these little pieces. So I mean, at least that's why it gives this bang, bang, bang like a nail gun. Anyway, look, it wasn't working, and I took it apart, and the worst about this, and I want to say I'm an electronic engineer, but I'm not a mechanical engineer, but I have to say these things are desperately designed, because when I took it apart, everything fell apart, so it wasn't even clear how I could put everything back together. Nothing was clear, so I just ended up with bits in my hands. But I do know I put it back together correctly, and then I plugged it in and operated, and it worked once. That's all. Then it stopped. After screwing everything back in, so all these multiple screws, 1, 2, 3, 4, 5, 6, 7, no, 2, 4, 6, 7 screws. Now here's something I had noticed, right? So there's 2 holes here holding down the electronic circuitry. That one there, which had a little screw, here, and this other one here, which had no screw, and I don't know where it went. But you know these standoffs, these plastic standoffs, I can see down there, that obviously cracked at some stage. And I don't know where the part went. It may have come apart when I took it, but so I had no idea what happened this. And then it struck me looking back into the past about a problem I'd seen once on a job I was doing on a machine in a factory. And there was two machines standing side by side. They were absolutely twins. And so without knowing anything about the machine or having drawings or anything like that, I just remember looking at the machines side by side. And then I noticed in one of them that it had one had a solenoid contactor, electromagnetic contactor, which was much bigger than the other, and obviously had been replaced there. And I watched the first operating machine working, and it worked fine. And I could hear a certain thud coming when this strikes. And if I get this going, I'll operate this so you can be able to hear. It's a sudden, very sharp bang as the solenoid goes in and out very quickly in order to provide that split-second hammer force. But what I'd come across was vibration. And so that left me to thinking, let's look at the electronic circuit board. One, it's not that I can't read resistor codes. I can't see these things anymore. But that particular problem on that day was there was quite a large electrolytic capacitor, much bigger than this. And actually, when I started to rock it, I could see there was a loose connection on the particular fault. So that led me to thinking about something similar. And this time I've opened it and I've actually focused on this. So this is the connector where the mains comes in here. Now, it is kept tight in there, so no vibration from there. But anyway, what you'll discover now, this is my 3 hands job, so I'm just going to have to try and put on a tripod. Okay, I've managed to put this on a tripod, so really interesting trying to do this sort of stuff. If I don't know anything about Edward Scissorhands, but if I had 3 hands, I think I could really do great work. I'd be a lot more productive as a species if I had 3 hands. Anyway, now I don't know whether you can see this. So here's the connector going in here. And when I started to touch it, it was rocking a little bit in my hand. So I don't know whether you can see this. You see, it's rocking there. So it gave me an idea. Look, if that's rocking, I just wonder what the connectors are like. So inside there, you can see whether it's soldered in. Now, again, I'd hope to try and use a magnifying glass. I don't know how that's going to work, but it didn't offer me that opportunity. So I just want to look in at this point here. So just look at if I'm going to try and get in closer in here into the, oops. Oh, this does zoom to some degree. Okay. So let me just see this connection here. So you see that? That solder connection is obviously broken. And actually, look at that. It's after coming away in my hand. See? So that solder link for both of those links is poor. Okay? It's broken. And therefore, what I was getting was an intermittent, and I'm going to try and stick it back in here. I was getting an intermittent connection. So I believe absolutely that this is the problem, okay? I've looked at all of the other elements of this device here. There's nothing. Now, look, if I get into the electronic circuitry, one, I've got a problem. For one, I don't have a copy of the circuit and very little equipment here to do any sort of analysis on it. But what I do have is, at least I managed to go and get myself a soldering iron. So the other thing is when you're remotely operating away from stores and all the rest, it's nice to be able to have a workshop and your gear and all the rest. So forget the fact that everything here is just in a this appears like chaos, but I would call it chaotic. There is a plan. It's sort of kind of non-linear, but anyway, so what I'm going to do is I'm going to use this temperature controlled soldering iron here, and I'm going to resolder those connections here. Right, so I'm going to set it up first and see if I can, so we can actually be able to see what I'm doing. Okay, I've set up a magnifying glass actually in between the camera and the electronic circuit board. So and I've turned it. There's a little light on the magnifying glass. Not really sure how I'm going to manage this. I'd hate to be doing heart surgery like this, guys. Anyway, there's my solder. I'll try the bottom piece first. I just need to clean that off. Yeah, let me just see how this one operates. I want to get that solder to flow again. Now in this case I'm going to try and hold that in position. Yeah, so I've put them in such a way that they've been held in position. Now the difficulty I'm having here is I'm having difficulty. I'm actually looking through past the camera in through the magnifying glass and trying to work on the other side. So I'm not sure how satisfactory that's going to be. I'll just take away the magnifying glass now. Okay, that was interesting. Let me just have a look here and see. Now the vibration, etc., is gone out of that. So just a comment to make about, you know, people often say, why you buy this. So I bought this tune in Aldi, and I bought it cheap. You know, you buy stuff in Aldi, and it's, I'll just take the, let's see. Okay, so I bought that in Aldi, bought it cheap a number of years ago. You buy it for the odd use. That's all I've made use out of it, was odd uses. But you know what I really can't understand is, in terms of quality, firstly, I think this design is terrible. I'm not a mechanical engineer, but I just don't think things should be wobbling all over the place when you take the cover off, that you break apart. That's just crazy stuff, and it should be obvious where to put things back. I think perhaps, now this thing's not new, you know what I mean? This is 2022 now, so this could be 10 more years old, had a lot of use. You can see the circuitry is all discrete components, so I'm not sure that you'd have that in the modern era now. And obviously if it was the modern sort of component, flow soldered and all the rest, vibration wouldn't affect it as much. But I would have thought that, given that, what I realise about this looking back now is this is all about the sudden massive impact, very short, sharp, concise impact, which is going to create a vibration. Now I would be prepared to say that that vibration is what cracked that little plastic stand that the screw was into, so it's relying on only one screw. There's not a lot I can do with it. I might put something, I don't know, can I do something, a dab of something to keep it from vibrating? That's what I hope to put back in. I'm not going to use this an awful lot. We'll show it later, just what I hope to do with this, a short clip of it. Anyway, that's I think that's operating. Now, of course, this probably wasn't big money. I don't know, might have been €20, might not have been that, you know. So the danger in our modern society, you know, it's much easier just go out and buy a new one than this, because where are you likely to have equipment and all, and the opportunity and the time, and you know, I come across this problem when I'm trying to do something else, realize it's not a 5-minute job, and they said, well, that's where I might make a longer video out of this. Does that matter? I don't know. Anyway, I'm going to put it back together. If I had enough fingers and hands and all the rest, I could probably video doing that, but you really don't want to watch this. I did manage to get it back together before. A delicate exercise, try to keep all the pieces in place, but I think that I can do that. Okay, the fiddly bits are all done now. I've reassembled the item again. It's a Craft P200 electric nail gun. And while I was putting the printed circuit board back in, I injected a bit of silicone into it as well. And when that settles, I hope that'll alleviate any other potential vibration in the future. I just wanted to just play it and run it just to see, give you the sense of why this vibration is very important. So when I press the safety button here and pull the trigger, you can see it shoots the nail out there, and I'm not going to shoot it into anything at the moment, but because really what I'm trying to just show here is the impact of the vibration. So you can see that there, very sharp shock, And looking back, that's what caused the problem. So if there's a lesson to learn out of this, a couple of lessons. One, as I said, there's no 5-minute jobs. That's one thing. I'm going to use this to nail or staple a sheet to the joists in the attic, so or the rafters. So we'll have a look at those in a moment. But the question is, should you just go and buy one of these, replace them, buy cheapy things in Lidl or Aldi or whatever? Is it worthwhile moving towards, you know, paying better money to buy tools like Makita tools with the replaceable LXT batteries, which that's the direction that I've chosen to go in. Should we just have a throwaway society? Should there be better mechanical engineering design in these things? I think so. I really think this is terrible design. And ultimately, the electronics as they're put together should have been better than that. So now from that 5-minute job of fixing the electric stapler to the what originally was the 5-minute job, which of course didn't turn out that way. So this little small attic in the second garage, I had the bright idea yesterday. Now these are all jobs I should have done during COVID. Makes me think of how damaged I was during COVID. I could have been doing all these things in the last 2 years, didn't do them, but I had lots of a couple of spare rolls of insulation, so I decided, so these are 4-inch rolls, I decided to stuff these in here, and I'm going to use this material here to just seal all that in, just for storage space here. So we'll see how that works, just to show you how the stapler works. I'll just throw it up against this one here, and you'll see it. See how the staple goes in there. So that's how I'm hoping to staple all this stuff. What started out as a 5-minute job, remember, there are no 5-minute jobs. Anyway, I started off a couple of days ago with this small attic. So just to give you an idea, probably rises 5 foot in the middle, so you can't stand on it. But I've insulated it, and then I've covered it with mostly, I suppose, the stuff you put under the grass for killing the weeds, for holding the weeds, and that matting, and some DPC on this side here. So now I can, well, actually what I'm going to put in here is my, to dry long term, is my cherry blossom cuttings, and maybe sometime they'll be able to be used for wood turning. Just a note on full disclosure here, because actually the job I started off with, the video with, was fixing the electric nail gun. That only lasted for, the solution lasted for about half of this roof, and, and the gun failed again. So I'm going to have to open it again. It's not this 5 minutes job. I presume the electrical connection at the connector, I presume it failed due to vibration. Don't know what I'm going to be able to do with it, and makes me wonder whether it's worth buying any of these cheap pieces, because okay, you buy them for a small job and all the rest, but then they end up just part of the junk pile, which is destroying the planet. Anyway, so I reverted to using this heavy duty Draper stapler. Actually, it was really powerful, though, although quite hard to squeeze down, because you control the punch with this little knob here. I have that set up quite strongly, but finished the job here quite well.